1,200 rounds per minute. This single statistic dominates every documentary about the MG42. Most accounts focus on the speed of the mechanism and the sound of the fire. But the real story is different. It is about how this weapon shattered Allied morale and forced generals to rethink the entire structure of the infantry squad. The Germans introduced a concept that changed combat forever. Even now, 80 years later, the design remains in active service. Modern armies still use variants of this platform. It was not just an improvement, it was a revolution. The timeline begins in 1918. The First World War proved that the machine gun was the king of the battlefield. It ended the era of cavalry and open field charges. But by the 1920s, Germany faced two massive obstacles. First, the Treaty of Versailles. The victors banned Germany from designing or producing heavy weaponry. International inspectors watched the factories. They monitored the steel shipments, but the restrictions failed. German engineers moved their operations to shell companies in Switzerland and the Netherlands. They used secret code names for blueprints. They developed weapon components in plain sight under the guise of civilian machinery. The second problem was tactical. The German High Command hated the stalemate of the trenches. They wanted a war of movement. They called it Blitzkrieg. At the time, the standard weapon was the MG08. It was a massive water-cooled machine based on the old Maxim design. The gun alone was heavy. When soldiers added the tripod and the cooling water, the weight exceeded 100 pounds. It required a team of 5 men to move and operate. It was a defensive anchor, not an offensive tool. It was too slow for a fast-moving army. The footage from that era shows the struggle. Teams of soldiers lugging iron frames through the mud. It was an obsolete way of fighting. The German military needed something light, air-cooled, and lethal. In complete secrecy, the project began. The goal was a universal machine gun, one weapon to handle every role on the battlefield. This was the beginning of the path to the MG42. 25 rounds. That was the capacity of the MG13 magazine. At a standard rate of fire, the weapon stayed active for exactly 2 seconds. The alternative was a 75-round drum magazine. It was bulky, prone to jamming, and unreliable under pressure. German command demanded more. They stopped looking for a simple infantry tool and started designing a universal system. The goal was a general-purpose machine gun, one weapon for every scenario. It had to fit on a tripod for heavy defense. It had to work on a bipod for mobile squads. It needed mounts for tanks, trucks, and aircraft. It even had to function as an anti-aircraft weapon against low-flying targets. Engineers focused on one design to rule the entire battlefield. The result was the MG34. Today, it is often overshadowed by its successor, but in 1934, it changed everything. It was the first true general-purpose machine gun in history. It featured a sophisticated belt-feeding mechanism and a system for rapid barrel changes. 1936, the Spanish Civil War began. Germany used the conflict as a testing ground for their new hardware. When the MG34 appeared on the front lines, the shock was immediate. No other military on Earth possessed a weapon with that level of versatility or fire rate. It was a technological leap that left rivals decades behind. But there was a problem. The MG34 was a masterpiece of engineering, and that was its downfall. Every unit was built from milled steel. Every part required high-precision machining and tight tolerances. It took 150 man-hours to produce a single gun. It was expensive, slow to build, and required a massive force of highly skilled labor. The footage of the era shows the reality of the field. In the mud of the trenches or the sub-zero temperatures of the Eastern Front, the weapon struggled. Those tight tolerances meant that a small amount of dirt or ice could seize the mechanism. If the crew didn't clean it constantly, the gun stopped firing. By 1941, the conflict became a war of attrition. Victory no longer depended on quality alone, it depended on raw numbers. The side that could replace lost equipment faster would win. The MG34 was too slow for a total war economy. The High Command issued a new order. They wanted a weapon that performed better than the MG34 but cost half as much. It had to be faster to manufacture and easier to maintain. Most experts thought these requirements were impossible to meet at the same time. German engineers didn't just meet the goal, they surpassed it. They utilized stamped metal instead of milled steel. They simplified the internal mechanics. They cut the production time and the cost by 50%. This was the birth of the MG42. The sound of the new weapon was a terrifying, continuous rip. It wasn't a series of shots, it was a wall of lead. Events accelerated. The new design was ready for the front. Thus began the era of the most feared machine gun of the 20th century. 1942. A new weapon arrived on the front lines. The MG42 was a radical shift in German engineering. Designers moved away from expensive milling. Everything possible was manufactured from stamped sheet metal. This process cut production costs and saved thousands of man-hours. The internals changed too. It utilized a short recoil roller-locked action. This mechanism allowed for a significantly higher rate of fire. Engineers purposely designed it with looser tolerances. In the mud of the Eastern Front, this was a survival feature. The weapon worked in grit and ice where its predecessor, the MG34, would jam. The facts were simple. The MG42 was cheap, it was fast to build, it was robust. Most importantly, it achieved a rate of fire that remains extreme even by modern standards. How fast did it fire? The Allies relied on machine guns that averaged 600 rounds per minute. The MG42 doubled that instantly. Depending on the bolt and ammunition type, it often reached 1,500 rounds per minute. It sounded like tearing linoleum. The footage shows a distinctive feature, the side hatch. This was the new quick barrel change system. In the older MG34, the operator had to unlatch and twist the entire receiver and stock. Then, he had to extract the barrel from the rear. It was slow. It was clumsy. The MG42 fixed this. A simple latch on the side unhooked the barrel. The operator pulled it out with one hand and slapped a cold one in. The sound of the latch clicking into place signaled the weapon was ready. A trained gunner and his assistant could complete this cycle in 4 seconds. But there was a drawback. 20 rounds passed through the barrel every single second. This generated immense heat. A gunner had only a few seconds of continuous fire before the steel began to glow. He risked melting the rifling if he didn't swap the barrel immediately. At first glance, it was the perfect weapon, but in reality, it had a fatal limitation for armored units. The Germans never mounted the MG42 inside their tanks. It could not serve as a hull or coaxial gun. The reason was the barrel change system. Because the barrel swung out to the side, it required massive horizontal space. Tank interiors were too cramped for this movement. Redesigning every Panzer interior was impossible. Consequently, the factories produced the older MG34 in parallel until the very end of the conflict. The MG42 moved toward mass production after a brutal trial. It first appeared on the Eastern Front in late 1941 for field testing. German commanders watched the results. They saw the carnage. They officially adopted the weapon in early 1942. The first full-scale deployment happened in the desert. Rommel's Afrika Korps received the new guns. British and American soldiers faced the weapon for the first time in the sand. It was a shock. Allied intelligence soon received a flood of panicked reports. The descriptions were consistent. The Germans had a new, superior machine gun. The Americans tried to copy the design immediately. They failed. 1942, North Africa. The British 8th Army faces a new sound on the battlefield. It does not rattle like a standard machine gun. It rips through the air like a mechanical saw. The weapon fires 1,200 rounds per minute. To the human ear, individual shots blend into a single, continuous roar. Allied soldiers give it nicknames. They call it Hitler's Buzzsaw. They call it the burp gun. But the names are not a joke. On the receiving end, there is no laughter, only suppression. The Allied command realizes their men are terrified. Morale begins to drop. The military leadership responds with propaganda films. They try to mock the MG42. They tell the infantry that the weapon is loud but ineffective. They claim it barks more than it bites. The films argue that Allied machine guns are superior because they fire slower. They say lower rates of fire are more controllable. They say The German gun simply wastes ammunition by hitting the same spot twice. The reality on the ground is different. Soldiers pinned in the sand do not believe the films. The MG42 is precise. It is devastating. When mounted on the Lafette tripod, it becomes a long-range surgical tool. Allied engineers scramble. They do not want to mock the gun. They want to capture it. They want to copy it. The German military built their entire strategy around this one weapon. This is the core of the problem. A standard 10-man infantry squad is not just a group of riflemen. It is a support system for the machine gun. 3 men operate the weapon: the gunner, the assistant, and the ammunition bearer. 1 officer leads. 6 riflemen carry Kar 98K rifles. Their primary job is not to lead the charge. Their job is to protect the MG42 team. The machine gun provides the firepower for both attack and defense. Logistics support the rate of fire. Each squad receives a donkey or a horse-drawn cart. They carry crates of heavy belted ammunition. Even the containers are superior. The German ammo cans are watertight. They feature specialized folding handles. The design allows a single soldier to carry 2 cans in one hand. In an emergency, a private can sprint to the supply line and return with 1,000 rounds of ammunition. Allied cans are bulky and awkward. Carrying 4 at once is nearly impossible without tripping or dropping the load. The footage shows the result. Intact MG42s in the hands of the enemy. The Allies now have the hardware, but they still face the tactics. Events accelerated. There was no turning back. Thus ended the era of slow-firing infantry. North Africa, Sicily, the Eastern Front. Allied forces captured dozens of German MG42 machine guns, along with stockpiles of ammunition. These weapons didn't go to warehouses. They were flown immediately to Allied laboratories for exhaustive technical analysis. February 1943. The Aberdeen Proving Ground in the United States completed its report. American engineers now possessed every measurement and mechanical detail of the weapon. They were impressed. The German design was fast, reliable, and technologically advanced. It was a leap forward in infantry firepower. The military wanted that power. They launched a formal program to reverse engineer the gun. The goal was simple: build a German machine gun that fired the American .30-06 caliber. This project received a name: the T-24. Why not just use captured German guns? The answer was logistics. Introducing a foreign caliber like the German 7.92mm would ruin the supply chain. Every crate of ammo sent to the front had to match. The Americans needed the MG42 speed, but with American bullets. The footage shows the first prototype on the range. It looked identical to the German original. But the internal components were different. At first glance, it was a perfect copy. But in reality, it was a mechanical disaster. Problems began immediately. American high command didn't want the German rate of fire. They viewed 1,200 rounds per minute as a waste of brass. They ordered the engineers to slow it down to 800 rounds per minute. To do this, the team manufactured a bolt twice as heavy as the German version. They added a stiffer, high-tension return spring. There was a second, bigger issue. The cartridges were not the same size. The German 7.92 by 57mm was short and fat, and the American .30-06 was 7.62 by 63mm. It was nearly a quarter-inch longer. This small physical difference changed everything. The geometry of the feed tray was wrong. The timing of the extraction cycle was off. The longer American casing couldn't clear the ejection port fast enough. The first test of the T-24 was a failure. The soldier pulled the trigger. 1 shot fired. The gun jammed instantly. The spent casing remained stuck in the chamber. The testers cleared the weapon by hand and tried again. The result was the same. 1 shot, 1 jam. The world's fastest machine gun had become a single-shot rifle. Engineers went back to the drawing board. They built a second prototype. This one could actually fire in full auto, but the reliability was non-existent. The logs tell the story. During a test of 1,500 rounds, the gun suffered 51 major malfunctions. It was failing every 30 shots. There was no mistake. The project was failing. The rate of fire dropped to 600 rounds per minute. This was the same speed as the Browning machine guns already in service. The massive weight of the new bolt had slowed the cycle too much. Worse, the heavy bolt created violent recoil. The metal frame couldn't handle the physics. Parts began to snap after only 200 rounds. The sound of metal shearing was common in the lab. American engineers spent months trying to save the T-24. They adjusted the springs, they filed the feed ramps, they redesigned the ejectors. Nothing worked. The American cartridge was simply too long for the German action. March 1944. The project reached a dead end. The military decided the T-24 was not worth the resources. They officially paused the program and shifted focus back to the weapons they already knew. The dream of an American MG42 was dead. The original guns remained on the battlefield, but the copies never left the lab. 7.62 by 63 millimeters. That is the technical measurement for the American 30-06 cartridge. It was too long for the original MG42 receiver. Engineers realized a simple barrel swap would not work. To use American ammunition, they had to redesign the entire weapon from the ground up. This killed the plan for a quick copy. The U.S. military could not field a German-style machine gun to level the playing field in 1943. Why did the project fail? The cost was too high, and the timeline was too long. High-ranking officers chose to stick with what already worked. The military doubled down on the M1919 Browning. They added a buttstock and a bipod to make it portable. They relied on the BAR for squad-level fire support. These weapons were reliable, but they lacked the sheer volume of fire found in German units. The Americans had one massive advantage: the M2 Browning. This legendary 50 caliber machine gun was too heavy for a single soldier to carry, but the military produced them in massive quantities. They bolted them onto every available surface. Tanks, trucks, half-tracks, fighter planes, and patrol boats all carried the weapon. German infantry hated the 50 caliber rounds. The heavy bullets tore through brick walls and light armor. In the final stages of the war, the M2 was everywhere on the battlefield. It became the primary source of American suppression. But the failure to copy the MG42 was not the end of the story. After 1945, the Pentagon reevaluated its doctrine. They looked at the German general-purpose machine gun concept. They realized the Germans were right. It was more efficient to have one versatile weapon than three separate systems for light, medium, and heavy roles. Was there a solution? Yes, but it required mixing different designs. Engineers looked at the FG-42 paratrooper rifle. They liked the ergonomic layout and the compact size. They also favored its gas-operated system for the new 7.62 by 51 NATO round. They decided to fuse this with the MG42 belt-feeding mechanism and its quick-change barrel system. This hybrid became the M60 machine gun. It entered service and gained fame during the Vietnam War. At first, the weapon had flaws. The early barrel change system was clumsy, and the reliability was poor. Soldiers nicknamed it the Pig, but the design evolved. Over 20 years, engineers ironed out the mechanical issues. Later versions became solid, dependable workhorses. The M60 appeared on jeeps, riverboats, and Huey helicopters. It had a rate of fire of 600 rounds per minute. This was half the speed of the original MG42, but it was easier to control. The influence of the German design is visible in the hardware. The feeding tray came from the MG42. The gas system came from the FG42. American engineers simply finished what the Germans started. The M60 stayed in the frontline inventory for decades. 1945. The war ended. The German military machine was dismantled and its weapons were confiscated. But the story of the MG42 did not end in the ruins of Berlin. The real twist happened years later. After the surrender, the Allies banned Germany from maintaining an army. This restriction lasted until the Cold War shifted the global balance. The formation of the NATO alliance changed everything. Why did the world want a Nazi weapon? The answer was efficiency. The Americans and Soviets weren't the only ones looting German technology. Other nations wanted the Hitler's Buzzsaw for their own arsenals. Yugoslavia acted first. They took captured German machinery and created the M53. It was a direct copy of the MG42 in the original 7.92mm caliber. They lowered the rate of fire slightly to save ammunition. Thousands of units rolled off the assembly lines. The M53 remained the standard Yugoslav machine gun for decades. But the biggest user of the MG42 was Germany itself. In the mid-1950s, West Germany joined NATO. They needed to rearm quickly to face the Soviet threat. The military looked at modern designs from other countries. They reached a single conclusion: their old weapon was still better. There was one major problem. The Soviet Union had seized all the original technical drawings for the MG42 in 1945. The blueprints were gone. The German company Rheinmetall had to take physical examples of the gun and work backward. They reverse-engineered their own invention. This led to the birth of the MG3. It was a modernized MG42 chambered for the 7.62 by 51 NATO round. The engineers added new vehicle mounts and improved the metallurgy. The finish was more durable, the weapon was tougher, but it kept the speed. The MG3 retained the original high rate of fire. To give soldiers options, Rheinmetall issued two different bolts. One was the standard light bolt. It allowed for 1,200 rounds per minute. The second was a heavy bolt. It dropped the rate to 800 rounds per minute. The mechanism didn't change. A soldier simply pulled the bolt out and swapped it. The difference in weight controlled the speed of the weapon. It allowed the crew to tune the gun for their specific needs. Germany still uses this design today. The silhouette on modern Leopard tanks is unmistakable. It is the same shape that appeared on the battlefields of 1942. But this was only the beginning of its global reach: the Lafette tripod. This single piece of hardware unlocked the full potential of German machine gun design. It transformed the MG34 and MG42 from light infantry weapons into heavy, long-range fire platforms. Even today, the modern MG3 uses a descendant of this mount, the Feld Lafette. However, the modern version lacks the most ingenious feature of the original. Why was the Lafette so effective? It was more than a stand. It was a precision instrument. The gunner mounted the weapon onto the frame. Integrated buffer springs absorbed the violent recoil of the high-speed bolt. This made the gun stable. It made it accurate at ranges where most machine guns failed. The gunner did not hold the weapon itself. He pulled a trigger built into the mount. This eliminated human vibration. The aim remained steady. In the frame, the gun sits low to the ground. The silhouette is minimal. The gunner uses a periscope sight. He can see the target while his head remains behind cover. The tripod also allowed for indirect fire. The MG became a form of light artillery. It could suppress areas the gunner could not even see, but the deadliest component was the Tiefenfeuer automat. What was the Tiefenfeuer automat? It was a mechanical search-fire mechanism. Imagine an analog computer made of clockwork gears. The crew preset the firing zones. They locked in specific elevation limits. Once the gunner engaged the system, the mount took over. The mechanism shifted the gun's aim up and down in a perfect preset arc. The gunner pulled the trigger. The MG automatically swept across the kill zone. It walked bursts of fire through a slope or a stretch of road. The crew did not need to touch the controls. This led to a terrifying tactic. The Germans sometimes tied a string to the remote trigger. They positioned the gun, set the arc, and retreated to a safe distance. They fired the weapon from deep cover. The machine gun would sweep the battlefield alone until the belt ran dry. Chaos followed. The enemy could not find the shooter. There was no one there. The MG42 changed global military doctrine forever. Almost every general-purpose machine gun designed after 1945 takes inspiration from it. The MG3 remains in service with over 30 countries today. It is usually mounted on tanks and armored vehicles. These modern platforms use advanced fire control to harness the high rate of fire. If a future conflict begins, this design will likely be there. The technology is nearly 80 years old, but the results remain the same. The era of the MG42 never truly ended.